Which of the following elements is diamagnetic? Okay, so first of all, to answer this question, what is diamagnetic? Atoms or ions, based on their electron configuration, would have different response when you put it into a magnetic field. Those that cannot be affected by the magnetic field are called diamagnetic. And the reason of that is usually because they don't have unpaired electrons. All the electrons are paired up and their spin cancels, and they won't be affected by the magnetic field. So understanding that, all we need to do now is to look at the electron configuration and decide which one doesn't have unpaired electron. Okay, so starting from cesium, on the periodic table, cesium has atomic number of 55. Once we know the atomic number of cesium, there's really no need to look at the electron configuration anymore. When your atomic number is an odd number, there's no way that you pair all the electron up. It's as simple as that. So cesium, gone. Germanium, 32. Okay, that's a good even number. Does that mean all the electrons are going to pair up? But when you have an odd number, it never would be pair up. So all those elements that have odd number of electrons, they are all paramagnetic. Yeah. But that doesn't mean all the elements that have even atomic numbers or even number of electrons would be diamagnetic because of their electron configuration. Let's write out the electron configuration of germanium. The last noble gas element before germanium is argon, and that's 18 electrons. So after that is 4s2, 3d10, that's 30 electron, and you got 2 more left, so we'll put it on 4p2. All of these orbitals are completely filled, so all electrons paired up. But here's 4p. Now, think about your p orbital. P orbital has 3 degenerate orbitals, and when you put 2 electrons on them, you have to put them unpaired with the same spin, and that means germanium would have 2 unpaired electrons, and that means germanium would be paramagnetic as well. Selenium, the Z equal to 34, so 2 more electrons than germanium, and that's going to give it the exact same thing with 4p4. 4 electrons, 1, 2, 3, and then 4. This is how we put the electrons in. Unpaired, same spin in each orbital, and then double it up. So with 4 electrons, you would have 2 unpaired electrons, and that means selenium is paramagnetic as well. Iodine. Look at the periodic table. Number 53. Neutral iodine molecule with atom would have 53 electrons. Even odd number, no way electrons can pair up. And since this is a multiple choice, that leaves us no choice but to pick zinc. But let's look at zinc anyway. Atomic number 30. Argon is 18. 4s2, so that's 20. 3d10, 30. Noble gas, all orbitals paired up. 4s2, 1 orbital, 2 electrons paired. d10, 5 orbitals, 10 electrons, all paired up. So no unpaired electron good choice.